Thank you. Hello, everyone. My name is Itır. As Johanna introduced me kindly, I come from SWARCO, Germany, and I will today try to give you an understanding of what CCAM is, together with some examples of some projects. First, this is another slide question that we prepared to understand what do you think, what do you know about CCAM, what CCAM is for you. You can, again, go to slido.com. If you're already in the app, you probably will see it. Feel free to pick the answer what CCAM means for you. You can also pick more than one answer. We already have some. I guess to see the results, we need to click. Maybe I need to click. Oh, yeah. Okay. 16 people already. Okay, we also have some people who don't know what CCAM is, which is why we're doing this training anyway. But it is nice to see that CITS has a high percentage overall. Let's wait 1 more minute. See? Okay. Automated driving going down. Okay, nice. Nice. We have 4% of the people who have answered who don't know, but generally it seems that there is an idea of what CCAM is. Okay. This is the question. Yeah. Do you think CCAM is important? This is the next question. You can again pick more than one answers, which you think fits.
I don't think it's important. I like it.
Yeah. Well, I hope we will change this idea by the end of this training. Affordability and accessibility going almost the same. Okay, nice. Let's wait 1 more minute to see. Okay. Okay, so let's start with a brief introduction of CCAM. I'm saying brief. It won't be that brief, but CCAM is a topic which we can talk hours, in my opinion, or even days. So I will try to give you some information about the most important parts of CCAM to understand what this is and why this is important. I want to start with why are we talking about this, after all? Why are we talking about CCAM today, and what would this bring to our transportation systems? Well, we know that cities are expanding. We know that we have a rapid urbanization. Today, more than 74% of the people live in urban areas in Europe, and this number is increasing more and more, with over 80% of people living in urban areas in North America. We see expanding cities, which brings more cars on the roads. And overall, we have more people wanting to travel from A to B. Overall, this results in environmental and social costs for our society, because we overall have a limited space only. You can expand cities only so much. And the problem here is that nearly over 100 years now, we already know building more roads, building more bridges will not solve our problem of congestion. These will result in having more congestion that we need to deal with. So we have limited space, and for this reason, we need solutions that addresses 3 pillars of sustainability, meaning quality of life, environment, and social welfare. We need to use our existing infrastructure in a more smart and efficient way. And this is where CCAM comes into play, because CCAM allows us to make the most of our infrastructure we have today and use it in a safer and more efficient way. What is CCAM? Okay, CCAM is basically a set of solutions and technologies that enables vehicles, infrastructure, and other road users to communicate with each other. This is a crucial, this is basically important to increase the safety and efficiency on our roads, and it also paves the way towards a future with full automation. It is also important, CCAM solutions also serve to integrate automated vehicles into the entire transportation systems. In other words, we can say that connectivity and cooperations are prerequisites for safe automation. It also enables concepts such as smart cities, mobility as a service, which we will be talking a little bit more in the afternoon, ITS, as well as connected and autonomous vehicles. I would like to also mention that CCAM is not only about vehicle technologies, meaning about autonomous vehicles, which we had a question, the Slido question was also interesting for that to see, because in most cases we see an approach towards CCAM focusing on the vehicle. However, I want to stress a little bit more why infrastructure is important. And we are not only talking about physical infrastructure, but it also includes digital and operational infrastructure, as you can see on the right side here. Before going into more technical detail, I want to give you an overview of where we are standing today and how these technologies are evolving. We are coming from traditional vehicles with internal combustion engines and traditional traffic management systems towards the future where we are foreseeing is fully autonomous and digital systems. And we have a 6-0 goals, meaning zero emission, zero energy, zero congestion, zero accident, zero empty, and zero cost. We're aiming for a future with electrification, connectivity, diverse use of mobility options, as well as autonomous driving. However, where we stand today, you can see the circle in the middle. We call this as the messy middle, because where we stand today is so-called the area with mixed use. We have vehicles on the roads with different levels of automation. We have road users that are not connected at all. We have cyclists, we have pedestrians. We also have traffic management systems with different levels of technologies. And it is especially challenging in this area, in this moment, to create solutions that are inclusive and safe and efficient for all. Also, I want to mention the fact that I don't have this picture here, but there was this nice picture of the Fifth Avenue of New York when, I think, taken around 1900s, where you would see horse carriages on the street completely. And just after a few years, the same picture again on the same road, you would just see vehicles. So what I mean is that these technologies may seem far future for us, but in my opinion, they will be on our roads sooner than we expected. Let's talk a little bit more why CCAM needs infrastructure. First, here I want to mention how the infrastructure can support the vehicle itself. From the perspective of the vehicle, we can divide this support into two. First one is the static. By static support, we basically refer to road markings or static signs that we have on the road. These are especially important for increasing the reliability and precise localization, especially in adverse conditions. We can classify these as addressing to the eyes of the vehicle. And then we have dynamic data and information, which is especially important for enhanced predictability and extended range of vision, especially in circumstances where we have low penetration of V2V, meaning vehicle-to-vehicle communication. Which is, in this case, we are basically introducing with the infrastructure, I2V infrastructure to vehicle and vehicle to infrastructure communication. From looking from a little bit broader perspective, how infrastructure supports CCAM, well, we know that overall it allows for a smooth and time-reliable self-driving journey experience. We know that it increases preserving safety of other road users, such as pedestrians and cyclists, especially today, as I mentioned before, where we have a mixed environment. It is also especially important from a transition from advanced traffic management to collaborative traffic management, meaning that traffic management will not be limited to adjusting traffic lights anymore, but it is towards a collaborative traffic management where the traffic management centers can directly communicate with the vehicles itself. And lastly, orchestration at a network level. This is especially important because with this infrastructure, you would have wider access to the entire network. Maybe some of you are already familiar with this Gartner hype cycle. This is basically a metric that we use for specific technologies to analyze their maturity, adoption, and social application. This one is for CCAM-related technologies. You can see that about 50% of these technologies are in the throes of disillusionment, which is also a positive. It also has a positive side, meaning that most of these technologies, many of these technologies, have hard work underway for commercialization, and we're likely to see them as a productive part of our ecosystem in the next 5 years. SWARCO basically envisions connected infrastructure here in the slope of enlightenment, because connected infrastructure, we're testing this since years now, and this is already a part of traffic in many cities. We're involved in more than 20 projects where we test and implement these solutions, which we will give some examples in the next slides. But let's before talk about the main European stakeholders. First, I want to mention European Commission. The European Commission has different directories that supports and gives advices to CITS-related applications, implementations. We have ERTICO, which Johanna have introduced in the morning. ERTICO basically develops, promotes, and deploys various CITS activities with more than 120 partners. ERTICO is also a long-standing partner of SWARCO in funded projects. Then we have these consortiums, Car2Car and 5GA. These are consortiums of OEMs supporting long-range and short-range communication, which I will talk a little bit more about these in the next slides. We have C-Roads, which is an umbrella platform for CCAM-related activities in order to allow a harmonized implementation. And on the right bottom side, you can see CCAM services kind of divided into 4. We have day 1, day 2, day 3, and day 4 services. And what we mean by this separation, you can also see the timeline below. Basically, day 1 services are the cooperation starts, it says, meaning that these services are also largely in operation already in many cities, where day 2 services are still mostly in testing phase. Now let's talk a little bit more about the infrastructure, how it can look like on the street. This is a very basic CCAM architecture that we have from SWARCO. Similar architectures are developed for different cities from different industry partners. However, I like this architecture because it shows it exactly on the street, so it's a bit easier to understand how these solutions can work. Here we have 2 solutions, time to green and speed advice. And we see 2 types of communication, short range and long range. Well, short range is based on radio broadcasting and are especially important of time-critical situations, so basically safety-related situations. Cellular network, on the other side, long-range communication. It is based on cellular networks. And we can say that some countries are more supporting short-range, some countries are more supporting long-range communication implementations. Some countries go for hybrid implementations, as these communications complement each other in most cases. And in this case, these two solutions, which I will talk in detail in the next slides, can be implemented by both ways. You can see, for example, in the short-range example where the vehicle is approaching to the traffic lights and the traffic light controller sends information to the vehicle regarding the signal phase information, so how much time you have left for the green phase and so on. It can also be implemented as speed advice, where the recommended speed is shared with the users to pass this intersection. As I said, I will talk a little bit more about these in the next slides. Okay, so to give you an overview of what SWARCO offers related with CCAM technologies, these services can be similar by different industry partners. I just want to share, just to give you an overview. We divide them into three, basically, to central, roadside level, and value-added services. From the central level, we have adaptive traffic control, we have advanced traffic management, real-time traffic information and event information. We also have services such as traffic light forecast. On the roadside level, we provide V2X communication roadside units for both long-range and short-range communication. We provide technologies for digitalized intersection communication with vehicles, infrastructure to everything, vehicle to everything. We provide services of V2X priority. Again, I will talk about this in the next slides. We also have variable message signs, which are CITS enabled. Value-added services, basically, we can provide individual green wave for drivers and cyclists, speed recommendation in order to avoid shockwave damping. Overall, we can say that SWARCO provides nearly the entire infrastructure necessary, technologies necessary for CCAM solutions. Here is a brief, is a simple graph. I want to show the projects that we consider as the key funded R&D projects regarding CCAM implementations. As you can see, these projects have started now over 10 years ago, and we have been testing CCAM solutions in these projects in various cities, various use cases. And we will be talking about some of these projects as well after the break today regarding CCAM. Okay, I will talk about in total 4 use cases in detail, but before that, let's look at the general overview of some of these use cases. We can divide them again as day 1 and day 1.5, meaning that day 1 services have the highest maturity and are in operation largely since around 2019 in several cities. The 1.5 services are the services which we expect them to be implemented in the next phase. I will talk about, for example, Roadworks, warning, prioritization, as well as speed advisory and emergency vehicle approaching in the next slides. Okay, the first use case is the prioritization. What is this about, basically? It is about vehicles approaching to an intersection and asking priority from the traffic lights in order to pass the intersection. So this solution is highly customizable, meaning that this can be implemented on to different modes, from public transport to cyclists. This is customizable in the sense that depends on the needs and policies of cities, each area, each city, and the problems, challenges of these cities. If we would give an example, so we can see In this image, for example, a bus is approaching to an intersection. It sends the request to traffic control traffic light controller in order to have a priority at this intersection, because, for example, the bus is behind its schedule. And the traffic light controller determines how to respond to the request and then gives the priority to the bus. But it is not only adjusting the specific traffic light that the bus is approaching, it also adjusts the other traffic lights. Here you can see in order to avoid potential collisions in the intersections. And this can be implemented, as I said, to different type of vehicles, emergency vehicles as well, cyclists, and so on. Or maybe electric vehicles when you want to promote electric vehicles. This overall, as we can see, increases the safety by avoiding unnecessary stop and goes. It also reduces fuel consumption for this specific given mode. Overall, it is also important in order to increase the efficiency in the entire in the entire network, and also by reducing travel times, or in other words, by increasing reliability. It basically increases, in this example, attractivity of public transportation. Second use case is traffic light forecast. It is basically the technology where you communicate signal phase information to the vehicle. We can classify this into two. First one would be time to green, where as I said, signal phase is communicated with the vehicle, so the information of how many seconds the vehicle has until the next phase, until the light would turn from red to green, or the other way around. So in this case, the driver has this information in a timely manner where the driver can adjust its behavior, his or her behavior. And for an example, when you are approaching to a traffic light and you receive that already it will turn into red in a few seconds, you know that you don't have to rush. You know that you can slowly decelerate, and overall you're avoiding hectic behavior on the roads. And again, sudden deceleration and accelerations are avoided, and we are reducing fuel consumption and increasing safety. The next example was a speed advice. In speed advice, additionally, the recommended speed is calculated and shared also with the vehicles. For example, it is given that the vehicle is driving with a certain speed. In order to catch the next green light, it needs to speed up a little bit. And this information is shared with the vehicle, so the driver knows in advance with which speed he or she needs to continue in order to pass. And this is especially useful when you have road sections with multiple coordinated traffic lights. Again, overall, we're talking about increased efficiency, reduction of fuel consumption, and improvement of the traffic flow in the road section, on the road section. The third use case is about roadworks and hazard warning. It's basically about communicating incident information with the driver in a timely manner. For example, when you have a road work, a lane closure due to an accident or a construction, you would probably be installing signs such as these ones you can see on the right bottom side. But with this use case, you're also communicating this information to the vehicle before, so that the driver, again, has the time to adjust his or her behavior. In this case, you're basically similarly avoiding hectic behavior, but this is also very important in adverse conditions such as thick fog and so on, where you have a higher risk of human error in order to, who can avoid these type of signs. You're communicating this information in advance so that the drivers have time to adjust their behavior. It is again contributing smoothening the traffic flow. and overall avoiding hectic behavior, sudden deceleration, sudden turns, and increasing the safety of the traffic network. Last use case is the emergency vehicle preemption. This is basically about communicating the existence of an emergency vehicle to the surrounding infrastructure. For example, we have this picture with an ambulance approaching to the intersection, you can see. And in this case, the existence and the location of this infrastructure is shared with the vehicles, so the drivers are able to know that there's an ambulance approaching even before they're able to hear the siren. So they have, again, time to adjust their behavior, to make space, to turn, to change their direction in order to give space for the ambulance. The same information is also communicated with the traffic lights, where the signal phases are adjusted in order to avoid collision. Also, the other ones are adjusted in order to prevent conflicting situations. And we are overall talking about the fact that this solution, again, increases the safety in such situations. It reduces the travel time of emergency vehicles, which can be an ambulance, which can be a police car, which can be firefighters. And overall, you're supporting the smoothing of the traffic flow by avoiding hectic behavior. This was the last use case, overall 4 use case. I hope it was not fast. But I want to ask you a question now, another slide of questions. Which of the use cases do you consider most relevant, most important for your city? Which of these use cases would benefit the most in your city? You can, again, go with the link or the QR code. Traffic light forecast. Okay, nice, interesting. Okay. Any questions so far? Any experience that you would like to share about CCAM implementations in Turkey? Where do you see CCAM today in Turkey? Are there any example projects that you can refer to? Or is it in the very beginning phase, in your opinion? Do you have any experiences that you can share? Feel free to mention anything you want.
I have a question.
Yeah.
For everyone. I was wondering, the person that wrote that CCAM is not important, if I don't want to put anyone on the spotlight, of course, but I would like to hear, or we would like to hear, why is CCAM not important? Is it so like far-fetched? Is it science fiction? Is it so much in the future that is not important now? Or is there another opinion or feeling in the audience?
I think it's putting too much on the spotlight. Maybe.
Well, you know, I'm not the one who wrote it, but I would like to kind of dwell a bit on that, because I live in the Netherlands, and the Dutch are working very, very much on connected, cooperative, automated mobility. But I'm Greek, so, and in Greece, and I guess in Turkey as well, you have the areas that are very much kind of pioneers and they're working on these things and smart mobility and cooperative connected automated mobility. But then you have areas where you don't even have signs. They're like outside the network. So if you discuss CCAM with these areas in Greece in the periphery, it's out of reality, let's say, still. So that is maybe something, or not maybe, that is identified as an issue by the European Commission, and that's why the European Commission, in its funding program, which is the Horizon Europe now, it's focusing very, very much on citizens' engagement. And they don't call it anymore citizen acceptance, exactly. They call it engagement, because acceptance is when you accept what is given to you or imposed on you. And engagement is when you see value on something, on a service or a product, and you actually see the added value, you see the urgency or the need for it, and you ask for it, you as a user, as a citizen, as a city. Because what is important for the European Commission and for the entire stakeholder network is that the industry, such as SWARCO or other, or automotive, they don't go on producing automated cars and nobody wants them, or people think it's science fiction. So it's very important to, speak up or write what you wrote, that it's not relevant, or because it's this exchange that is going to help everyone work on something that works for the entire user, or all the user groups. Okay, that's me discussing this on your behalf. But it would be interesting if we had somebody giving us some feedback from the audience, if CCAM is important, or how is the situation in Turkey. Don't be shy. This is an interactive training. You can also say it in Turkish, and then we have it here translating it in English for us. Esma.
I guess there's no one who is eager to answer your question. So what's our experience with CCAM in Turkey? Actually, we are getting prepared for CCAM services to be implemented in Turkey. We have identified 7 prioritized services which are identified by the European Commission, and we aim to deploy those services in Istanbul in around 30-kilometer highway, and we will implement those prioritized services, connected cooperative CIT services on this route. We hopefully aim to start the project this year.
And this is a national one?
Yes, it will be a national project which is supported by the Ministry of Transport, and it is implemented by the Director General of Highways.
Fantastic. Yep. Excellent, excellent. And I'm going to tell you, we're going to give you some examples of projects, and one of the projects I'm going to be presenting in a very short set of slides is involving CCAM in a corridor between Greece and Turkey. But it's one of these things. Things happen in your country and you don't know about them all, of course. So yeah, great. That's a great plan and a great strategy from your ministry, from your government. Okay, let's see. What is next? 10 minutes break. There you go. 10 minutes break.